Well, good afternoon again, and a very, very warm welcome to our final discussion in this bite-sized corrosion series where we've been looking at galvanizing in perspective. So a special warm welcome back to you, Rob, and thank you again for being so willing to share your expertise with us. In our time together, we've been looking at what galvanizing is, how items are galvanized, where galvanizing is used. But perhaps if possible today, we can spend a little bit of time looking at how we can determine whether galvanizing is suitable and how we can ensure that we get what we're paying for.
Yeah, I think, during the very first discussion that we had, I said the thing about galvanized structures is that they seem to be here, there, and everywhere. And whilst this isn't particularly scientific, I've always advised people just to look around themselves and see what there is that's close by. And maybe you get some pointers from that.
I think standards are probably how we can see what we know, what we're getting, if we can put it that way.
Yeah, I mean, there are so many standards that we could all get a raging headache. But I think before I start, just from the point of view of clarity, I will focus on the ISO standards. Very short digression is that the Bureau of Standards here, in South Africa is a member of the ISO. As a consequence of that, they are able to overwrite ISO standards. I will focus on the ISO standards. They don't have the same agreements with people like the Euronorm Committee or the ASTM committees.
If we see a standard number, we can look for it either as an ISO standard or as a SAB standard.
Absolutely. Yeah. Europe is now harmonized with Euronorms, and all of the Americas, North and South, tend to use the ASTM standards. But what I would suggest for people who are listening in now is maybe have a pen and some paper handy, because this could very quickly become a high-speed car chase. So let's start off with trying to actually define the environment and the fun games that we can have as a consequence of that. Fortunately, if we look at the ISO 9223 standard, which is the standard reference of corrosivity, it includes zinc as one of the four metals that it looks at. You've got steel, copper, aluminium, and zinc. Zinc is actually used within the classification system itself. So you go from a very benign C1 environment, which would be almost, well, essentially an indoor environment, right through to an aggressive CX that is basically C1, 2, 3, 4, 5, the CX environment. And the corrosion rate is then defined by the amount of zinc that you lose in terms of weight loss. And I would certainly recommend that any specifier should be familiar with that standard. I think it's quite complicated if you try and start referencing other things, but 9223 is probably the first thing you should look at. And in addition to that, a lot of countries have put together corrosion maps. Now, they are a broad brush approach, but I would say to people, please have a look at those as well. There is one of South Africa, and normally we would specify uncoated hot dip galvanizing in either a C3 or down to a C1 environment. Above that, you probably overcoat it with an organic coating, as we discussed last week, which is known in the industry as a duplex system for more aggressive conditions. But I would just now caution people in terms of when you use the standards, going back to try and find the reference. So I've put together a few slides, and if we can just have a look at those, it will define some of the dramas that we can have if we don't sort of look a little more carefully as to what is around the area where we will be specifying a corrosion protection system. ISO 9223 classifies the environment, say, by looking at the four metals, but in addition to that, it has things like time of wetness, which to some extent depends, then it defines the humidity, temperature, rainfall, and what else have you. Now, this is a map of data that you can get down in Cape Town. I've got a little cross, I think, in one of these slides. And you'll see it's got the amount of rain in green. You've got the maximum temperature. You've got the average amount of sunlight, the days with frost, which is not particularly great. And if we move on to the next slide, you will see that it becomes quite interesting from the perspective of humidity. This is a map taken from a book that was written by Dr. Brian Callaghan some years ago, and it's essentially a humidity plot. So you've got the months of the year, then the hour of the day, and you can see from that, if you look closely, and you do have to look closely, the light areas are where the humidity is below 70%, and the dark areas, and then the contours you see is when the humidity increases. And one of the things that we all know is above about 70% is when you start getting condensation onto the surface, and therefore you have the start of your corrosion cell. The X is where the station was for that. This is a windrose and in the middle of False Bay. And what I'm really trying to show here is that the wind, as we know, is generally from the southeasterly. There is also wind that comes from the north. If you look at Muizenberg, if you can see where Muizenberg, one of the things about particularly within the Cape Peninsula is that, yes, the wind normally is from southeasterly. Because of the mountain, you lose sunshine depending upon the time of the year, anything from 2 o'clock to a little later. And although the wind does blow from the perspective of having this southeasterly, it doesn't really carry much rain with it. So you don't get the washing, but the wind can be very strong. So you can actually get salt spray and the like, but you don't get the washed away. But this is using the broad brush 9223 approach. This was some work that was done about 4 or 5 years ago, just as an illustration of some of the issues that relate to the coastal railway going from Muizenberg to Simonstown. So you can see you've got in the Cape Flat area, the C5M, C5, and then the C4 environments. But if you look at that, you would say, well, yeah, okay, I can classify the environment, but let me just show you something to boggle the mind a little bit. This is not actually the catenary pole, so ignore the catenary sticking out there to the left. But if you look at this, you can see Simonstown in the distance, or it's probably Fishhook in the distance. This is taken from the Muizenberg position. You can see from the funny little, from the shadow there, what we're actually looking at. And this is clearly facing directly onto the almost south. And if you look at that galvanized structure has been there about 20 years now. We're now going to move around. So we're walking around in an anti-clockwise direction. So we're now staring out to sea, and you can see that there's a fair amount of corrosion there. It is sheltered, so it's getting the sea spray, but it is getting sheltered. It's probably not getting washed away. This is the same pole. So let's now look at from another side. We're now looking from the seaside, and you can see some fairly nasty looking corrosion there. And just then to move on to the last one, you can see from this position here that it is fairly badly corroded. And that's as a result of that southeaster bringing salt spray, but there's no real washing going on. The point of what I'm trying to explain here is that, yes, the 9223 standard is a good guide to some degree, but one just has to be careful because it depends upon the way in which the wind blows without bursting into song, and temperature, closeness to the sea, and the like. And I think that a practical approach should always be taken once you've actually tried to define the environment to a greater or lesser extent. That's all I'm really trying to show you.
That's really helpful. And it's quite interesting that on one light pole, it really does reaffirm that sort of perspective that whether something will work or not depends on the perspective from which you are viewing the problem. And from the one side, you go, this is all fine. And from the other side, you go, whoops, we have a problem. Just moving on from that, in light of classifying our environment, we can obviously then determine, is galvanized infrastructure, as you say, useful or viable, or does it need help? But obviously, when we are choosing what we want to do in terms of corrosion protection, there are costs associated with it. When we are galvanizing, do we have any way of being reassured that we confidently are going to get what we want? Are there standards that can define the galvanizing in that regard?
Yeah, this is where we could now have a nice fallout with maybe some of the galvanizers. I mean, the corrosion protection world is very mature. What one really needs to work out is, well, I've now decided what I'm going to do, and how do I ensure that it can be galvanized, which includes things like design and everything else. Now, the actual gold standard, and again, pen and paper, is the ISO 14713. This covers the whole range of zinc coatings. And part one discusses the range of coatings that you can use and some practical design aspects for good galvanizing. and also covers builds upon 9223 in terms of whether it will or will not work and what one needs to look at. Part 2 provides more detailed design. It actually gives you design element considerations and references as to how the steel properties, by which I mean the stresses you may have put into the steel in fabricating items, and how they could impact on galvanizing. And I would strongly suggest that people get hold of parts 1 and part 2. That really is critical. Part 3 covers Sheridizing, and essentially it's the build of part 2, but with relevance directly to Sheridizing. So I think the 14713 parts 1 and 2, people should own a copy. In terms of the actual general galvanizing itself, so we've now worked out how the steel should be fabricated so it can be galvanized. We now want to galvanize it and ensure that we actually do have good galvanizing. Then the standard to ensure that you get what you pay for is 1461. Bit of a drama in terms of, in South Africa, there is also SAMS 121, which is essentially equivalent to 1461. God willing, in a few deaths, eventually 121 will disappear and we'll all use 1461 and move on. For people who, like me, are fairly simple-minded, there is a degree of equivalence. In the ASTM standard, so you don't need a piece of pen and paper, is ASTM 123. So generally, most people can remember. And if you go through the 1461 standard, you should be able to get what you've paid for. Just as a bit of a punt, the Galvanizing Association here does offer an inspector's course, which you don't have to necessarily be an inspector to do the course. You do get CPD points, and that really gives you a good insight into the workings of 1461. Just as an aside, and this is where I digress a bit from the ISO, for those who are looking to export structural product into Europe, you have to get the CE marking. And rather than fight your way through EN 1090, which is not a riveting read, I would suggest that you get hold of the European General Galvanized Association. They have a guidance document, so you can use that. And then just to sort of wrap up in terms of decision making, if you're going to overcoat general galvanizing, you really only need one table in one standard. If you have a friend who actually has ISO 12944 part 5, all you need to do is copy table A9. And that really has the choice of organic coating you should put on a galvanized surface depending upon the environment. And it has the 3 classifications the heavy duty coatings industry generally uses as their guide in terms of decision making from that point of view. Mm-hmm. There are 2 old guides which should still be available, probably from the Galvanizers Association. They were done in 1990, so we are talking some years ago. But one is the Code of Practice for Surface Preparation and the Application of Organic Coatings. That's still relevant. The second one is the specifications for the performance requirements, which is really back to 12944. But the difficulty with that is it's using coatings that probably are no longer available.
Rob, before we move off the sort of specification bandwagon, a question that's just come in from the floor. ISO 9223, you mentioned, classifies the environment. How does that compare with the environmental classifications in ISO 12944, which is the coating standard, which also classifies the environments? Do you think there's been synergy in the 2 standards?
They are essentially identical.
Okay, great. That's encouraging to hear.
A 30-second digression. The 9223 standard was actually done by a Czech lady, and it was done as part of the United Nations program. And they found that the noses were falling off the marble statues in Italy because of poor air quality. And that particular, it was called the ISO CORAG program. And that program ran for a number of years. And then out of that came the 9223 standards.
So hopefully that's a standard that won't put your nose out of joint. Then Rob, we spoke last week about the water piping market being quite big. Obviously, the standards you've already mentioned will cover, I'm sure, the galvanizing of water pipes. But are there additional requirements, particularly when you think of the fact that these are potable pipes and there's that sort of aspect as well?
Yeah, I was fortunate to be able to visit a lot of previous studies that have been done by organizations such as Mintec and the CSIR. And myself and the late Dr. Tony O'Donnell and the Bureau actually published a recommended practice document, which should still be in print. And the pen and paper story is it's the ARP 060. And my interest really came from hands-on experience of some of the work that I'd done in the Middle East, using work that was done at UCT in the early 80s, which was sponsored by the Water Research Commission. And secondary recovery of oil is actually carried out using either high temperature water or steam injection. Naturally, the water does cool. If you want to get fired, have it scale and block the oil's pathway to the recovery point. So I used the UCT studies, and remarkably, it actually worked. So when I came back to South Africa, I just saw the gap, and the tables from the ARP document have been reproduced, fortunately, many times. And so, yes, you can use hot dip galvanizing in the water. The ARP document covers everything. And in brief, the idea is that the pH should range between about 12.5 and 5.5. It should be mildly scaling, tied into some extent to the pH range. And in terms of the corrosivity index in terms of scaling, so you can use the Langella or whatever, but there is actually a term called the corrosivity index. The water should not be anaerobic. And I think, as I mentioned in my last talk, there should be a degree of reserve alkalinity. Now, before sort of people started saying, well, that's a bit of headache material, there are simple guidance documents that have been produced by the Galvanizing Association using the AR. They're all based on the old ARP 060 work, and they are information sheets 3 and 6. In terms of galvanized steel tubes specifically, one should refer to the SABS or SAMS 62 standard and SAMS 32, which is a carbon copy almost of the EN 10240. So just remember SAMS 32. We did a lot of work on galvanized tube product development. And I have to say that providing it meets, the galvanized piping meets the SAP 62 standard, which also includes, don't have time to go into it now, but internal weld bead control, it will perform. So within those documents, all the information that you would need in terms of will it work or will it not work, that's all there. And just as a short aside, myself and Tony were going to produce a similar document on buried pipelines, but the Bureau at the time was going through some traumatic changes in life, and our enthusiasm waned somewhat. But fortunately, we've done all the proof work, and that is already informally out there. And for those people who are listening in who think they are whizzes at computing, I did actually, in conjunction with one company, we developed a program which would actually define the suitability or otherwise of hot dip galvanizing, both in atmospheric conditions and in waters and in buried applications. Unfortunately, it only works on Windows XP. It lurches a little on Windows 7, but by Windows 10, it just sort of explodes and you don't go anywhere. So anybody who fancies developing an app, I have all the original files.
Well, I certainly won't be taking you up on your offer, but someone who's more computer literate than I may well. Obviously, everything we've mentioned so far deals almost exclusively with your batch galvanizing. I presume there are also standards available for continuous galvanizing and where that's used?
Yeah, again, the standards that you need to look at is the Common Structural Galvanized Coil Standard is ISO 4998. And then ISO 9364 covers the zinc 55 aluminium coils. Now, with regard to the latter, myself, Tony, and GT Van Rooyen at UP produced a brief on the basic coating properties of the zinc 55 aluminium. That is available. Both coatings can be obtained off the shelf pre-painted. And I would actually recommend that people then get the company documentation. I say that because there's really only the two companies involved. One is Saffold Steel, the other is ArcelorMittal or ARMSA. And the documentation that comes from both of them has some useful pointers again as to the environments where these materials will or will not work. But importantly, it also covers quite a lot on fasteners. And if you remember from last week, that is a perpetual issue. And it's quite pleasing to see that they've included that in their documentation. If you're looking for just a backup reference for pre-painted metallic substrates, That's SANS 1845. So that is a local standard. That took 20 years, I think, to get through the system. And galvanized light steel framing for buildings is showing very slow growth. It is beginning to grow relatively rapidly in Africa, mainly for roof trusses, because you're taking a structure from wood to steel. That's relatively easier than moving from brick to steel framing, because everybody thinks that really you just got a tent, and how secure is it? And I said that the roof framing is very common from Ethiopia all the way down, even into Mozambique. So, and I think those who are interested in that should look at SANS 517. That is an exceptionally good comprehensive standard for anybody who wants to use light steel framing. In terms of wire, that is used extensively in the agricultural industry. A lot of people don't realize is that a wire fence on a game farm is your single largest capital outlay. So if you look at a 7-strand with all the droppers and the rest of it, there's a serious amount of money involved. And some years back, we revised the SAPS standards and produced a series of guides. Those guides cover everything from fencing, posts, droppers, you name it, where to use it. And that was done with the Agricultural Research Council, Bureau of Standards, and the SA Wire Association. And curiously and pleasingly, those documents are available through the IZA Africa desk. The upgraded standards are SANS 675 and 935. For those who want to look at some of the international ones, there is SANS EN 10244. So SANS were able to copy the EN 10244 standard, and that covers Galvan wire. And the reason I mentioned that is Galvan wire is used extensively, as I've mentioned, in gabions, and also rock embankment restraint nets to stop rock falls. So applications such as it's used widely in Reunion, it's used widely in Mauritius. It is also used in Chapman's Peak.
And that's quite important. Not always as successfully as it should be, perhaps. Wow, Rob, I'm always in awe of people who can keep numbers in their heads. I struggle. So hearing you just spew out these references is quite awe-inspiring. I know that I'm going to have to go and watch the video on slow replay to get them all down. But are there any other places that we can get information that you would take the opportunity to punt?
I mean, the two local ports of call would be the local Galvanizing Association, and certainly the International Zinc Association, the IZA. They have their Africa desk in Cape Town. The association produces regular journals. These are all available on their website as downloads. And I'd recommend that you get hold of specifically their steel protection guide. And that covers a lot of the detail in terms of everything from how to galvanize through to defects that you should shout and scream about. They used to produce a small pocket guide. I haven't seen that for some time. The IZA has produced, the Africa desk has produced an excellent reference document called The Essentials of Galvanizing. And that book I would strongly recommend, not just because it gives examples, but also it covers the 14713 standard, which as I said to you, is really the key document. The other standards fall into that more than anything else. I mean, further afield, for those people who are interested in coil products and the like, the IZA internationally supports the Galvinfo Center in the USA. If you just Google Galvinfo, so it's GALV info, all one word. And then finally, the European General Galvanizers Association, which is a consortium between all the national galvanizers within Europe. They produce an awful lot of documentation. This is their latest production for.
Wow, okay.
So locally, the Galvanizing Association and the IZA Africa desk, and then internationally, you can go to the IZA website, put in IZA, or EGA, which is and you just put in I think it's ega.com. It really is quite simple to find. So those would be information ports of call where you should be able to get answers to any of the queries or questions or issues that we've been unable to, because of time, to actually address.
Well, thank you, Rob. Thank you so much.